All right, this is the Algebra 2, Unit 1, Lesson 8 video. This lesson covers a lot of material. I would expect exponential, radical, and rational functions to be covered over the course of multiple units, not just one lesson. So this is going to be a very, very surface level overview. And what I want to focus on is knowing what those three things are. So the first thing I want to talk about is rational expressions and rational equations. So rational, the key word, or the key part of that word rather, is this ratio. And if you remember, ratios are fractions. So when we talk about rational expressions and rational functions, or rational equations, we're talking about algebraic expressions and algebraic equations where there are fractions that involve variables. So again, we know ratios refers to fractions, okay? But in a rational expression, you have things like this, x plus 2 over 3x. So this would be an example of a rational expression. Because remember, expressions are just kind of groups of numbers and variables. They're not really, the distinguishing thing between an expression and an equation is, in general, is that expressions don't have an equal sign. So this would be an irrational expression, whereas we also have rational equations. Okay, so a rational equation is going to look like something like this. X minus 2 over x equals 3x plus 7 over 4, or whatever. So this would be an example of a rational equation. Again, the key here is that rational equations have an equal sign in them, whereas expressions do not. And that's kind of the key thing I want you to kind of take away is, what does a rational expression or equation mean? It means it has fractions with variables, and expressions do not have an equal sign, whereas equations do. And that same idea is going to continue as we keep going, because the next type is radical expressions and equations. Radical refers to things that have square roots. We call square roots radicals. And so radical expressions are any expressions that have a square root in it, but also variables. So this would be a rational expression, whereas a rational equation would be the same type of thing, but one in which there are an equal sign in it. So it would be something like this. Let's see. 10 equals the square root of x plus 2. So the difference between an equation and an expression is simply that one of them has an equal sign, an equation has equal sign, and expressions do not. But the thing that joins them and makes them radical is that they have a square root in them. Okay, last terminology. Exponential equations. They don't cover exponential expressions. We're going to jump straight to equation. You know what equation means. But in exponential equations, there are variables like x that are functioning as exponents. So it is not talking about this. That is not an exponential expression. That is a quadratic expression. Exponential would look something like this, 3 to the x power. That is exponential. So then an exponential equation would look like this. Y equals 4 times 3 to the x power. That would be a rational equation. So just to review, the three main topics here: rational. Rational refers to fractions that have variables. Radical refers to square roots or cube roots or other types of roots that have variables. And exponential equations refer to equations where the variable is an actual exponent. Not that it has an exponent on it, but that it is the exponent, like you see here. All right, so that's kind of the first main part of this lesson, is just some basic terminology. So you'll see that when you get down to number 1, number 2, they are just asking you about those different types of equations and expressions. And there's some other vocabulary as well, so make sure you just kind of read through and find those words that you need to answer some of these questions. In particular, like this form of an equation. But you should be able to tell what kind of equation that is because you see that X right there and what that means. So then it gets down to a whole other concept dealing with finding the solutions to these types of equations and this idea of an extraneous solution. So I'm going to try to do a pretty brief explanation of what an extraneous solution is. An extraneous solution is a solution that you can find by using algebra, but you cannot find if you look at the graph. And these two questions are great examples of how that's done. So I'm going to just tell you kind of exactly what you need to do to solve these two equations. And so really it's very simple. Because you can see that we have these two being equal to each other, I'm going to graph both of these equations. And we know from our experience that when we're trying to find the solution of two things, we're looking for where those things cross. So we're going to first just go and we're going to go look and see if these two things have any intersection points. And when I say two things, I mean square root of 4x on one side, x minus 3 on the other. So I'm going to jump over to Desmos and we're going to type those equations in there. So we're going to do square root of 4x and x minus 3. Okay, so we can see clearly there is one place where those cross. Specifically, they cross at the point 9, 6. Write that down here, 9, 6, which is an xy point. So the x value there is 9. That's the one we're interested in. So let's jump over here and see. We see that we do have solutions for 9 here, here, not here, not here. And then we have one here as well. So the question is 9 a real solution or is it an extraneous solution? And we know it is real because we can see it on the graph right there. That shows us that this is a real solution. So it is not one of these extraneous, because remember, extraneous solutions are ones that don't appear on the graph. So then the question becomes, what about this other number? We have an x equals 1 here and here, and hopefully, just using logic, you can understand that because there is only one intersection point on our graph, then we know that 1 is not a real solution. It is an extraneous solution because it doesn't appear on the graph anywhere. So then that makes it clear that answer choice D, x equals 9 being a solution and x equals 1 being an extraneous solution, is the correct response for this question. I know I kind of just walked you through that, but I'm going to let you do number 4 on your own. So you need to graph two functions. You need to graph this function and you need to graph this function. I would recommend using parentheses around this x minus 2 to make that fraction. But when you graph those, the question becomes, is there just one intersection point, or is there some way like 2 intersection points? And if there are 2, you need to find the answer choice that matches those 2. If there's just 1, you need to find the combination of these other answer choices that fits the solution that you found. And I think if you give that one a try, graph it, I think that it will make a lot of sense once you see the graph. So reach out to me if you have questions about number 4. I can send a solution your way. Other than that, that's it for lesson 8.